Algebra 2 students. So this is 5.5 function operations. So we're going to be combining functions and doing what we call composite functions. The first thing we're going to do on day 1 is combine functions by addition, subtraction, multiplication, and division. And then the biggest thing to learn here is make sure we can identify the domain for the resulting function. And then on day 2, we're going to compose functions. We're going to specify the order in which the functions are applied, and then also describe the domain of the composite function. The essential question is, how do we combine, multiply, divide, and compose functions, and how do we find the domain of the resulting function? We do want to make sure, I like to put the smiley here to make sure my pen's working. We do want to make sure we understand these two vocabulary phrases. One is the composite function and one is the composition of functions. And we're going to go into this in a little bit. When you see the word composite, you can think of the word combine. So it's a combination of two functions. And a function just as y equals something or the other, right? Or f of x equals something or the other. It could be rational. And then the thing that's the key here is the output of the first function is the input of the second function. And once you get that, you get the order of how you're doing your mathematical procedures. So the output of the first function is the input of the second function. So I have some function here that does something to x. You put x in here, it comes out, and maybe it comes out to be, maybe all I did was add 1 to it. So it comes out as an x plus 1. Then I take that result and put it into my second function. Maybe this time I'm going to square it. So I've taken whatever my x is and now becomes my new x. And now my output would be x plus 1 squared. So maybe this is my first function, f of x, and this is my second function, g of x. We'll talk about that a little bit tomorrow. Now the composition of function is just the operation that forms the composite function. And we designate it with a little circle. You might remember some of this in geometry, something similar, a similar idea. So in this case, it would be g of f of x. So this is my composition of functions over here. That's what I'm doing. I'm taking whatever I get out of f of x, and that becomes whatever I get from this. The output of this becomes the input of this. Here's something to look at, and here's something why we do composite functions or combining functions. First, we're just going to do some combining of functions. And we do this all the time when we have more than one step that we're doing when we're dealing with money, right? We do this a lot. So this is good for the business application here, and we're going to think about this a little bit. So we've got a groomer. He's charging $25 for every pet that comes in. And the profit is the difference. So that means I'm subtracting difference between revenue, the amount the company earns, and the amount the company spends because they have to pay for things, right? You have to pay for your tools, your equipment, your people. You have to pay them. All right, so you could say profit of something, maybe that's the number of pets that come in, would be the difference between my revenue, so how much I charged, got paid for it, and I would subtract the cost. And that probably depends on an X too. In this case, we're going to make sure it does depend on the X. All right, so we have a groomer that charges $25 for every pet that's groomed. X is the number of pets groomed in a month. Define a revenue function for the business. So revenue is the R of X, and basically we'll get $25 for every pet that gets groomed. That's my deal. Now the materials and labor, and we're bringing it down to a month, they cost, for each pet, it costs $15 for the materials and the labor. And then the business has fixed costs that are $1,000 each month. And that could be the overhead, the rent, whatever. So now we need a cost for the function for this business. So the cost would be, it'd be $15 for every animal. So what's it look like? They're only making $10 on each pet, right? And then it's also going to cost $1,000 every month. So last month, the Grooming USA groomed 95 pets. Did they earn a profit? Well, let's look at the profit. Whoops, that's weird. The profit would take my revenue, which was 25x, and my x is 95. So I'll just put the 95 in there. And then I would subtract out the 15x, but I'm subtracting both of these, right? 15 times 95. And I'm also subtracting the $1,000. Well, when I did the math here, I ended up, looks like, I think I ended up with a negative. Let me double check that. I'm going to stop just a second. But so my profit, one day I'll figure this thing out. My profit right here was actually not a profit at all because it was minus $50. So if they groomed 110 pets, then I could do the same thing and do the 25 times the 110 and subtract the 15 times the 110. And the 1,000 is the same no matter what. But still, they only made $100, and they might need to change something because that's not a lot of money to make in a month for all that work. So they might have to adjust something, try to diminish their costs of some sort, or increase the charge for the pets. They want to make more than that, or maybe advertise more to get more pets in. So a lot of options there. When we add and subtract functions, we can use this symbolism right here, f plus g. So if f of x is defined to be this function and g of x is defined to be this function, f plus g would just take 3x plus 4, and then you would just add x squared minus 5x plus 2. And there's nothing new or complicated about this. You've done all this before. So you take the x squared, because it's all by itself, and how many x's do I have? I have 3x here and minus 5x there, so that gives me minus 2x's. And then I have 4 plus 2 just hanging out by themselves. So that's the answer there when you add those together. And I apologize, you can't see all of the bottom, but the domain of f of x in the set notation looks like this. X is a real number, so x is less, I was going to say, and you could do less than infinity or greater than negative infinity. Let's do it this way because we're kind of used to that. And the domain is the same thing. It's any real number. Sometimes I do this for a real number. And then at the bottom it says the domain of f of x plus g of x is also a real number, All right, so here the domain and the range, the domain of each one is the set of real numbers, and so when I add them, I also get the set of real numbers. When we start dividing, that's when we start limiting things like that. And when we have real world applications, a lot of times we have to limit the domain. So let's subtract these functions, and it's just written like f minus g. That means I'm just subtracting the function. So I take the 3x plus 4, that's my f, and I subtract, and I'm going to put this in parentheses because sometimes I mess up if I don't put the parentheses in there, minus the g of x. You could put that in parentheses too, but it doesn't change anything. All right, then I'll rewrite this. Now the minus 1 means I'm basically multiplying everything by -1. So instead of x squared, it's subtracting x squared. And instead of subtracting 5x, I add. And then do the opposite. Sometimes people will do this too. I've seen this as a way to remember. I just change that sign, change that sign, change that sign, change that sign. Helps if you have a different color for that. Now I would combine like terms, but there's only one of those, so I'll do -x squared. Here's a 3x and a 5x, so that gives me 8 x's. And then a 4 and a -2 would just give me 2. All right, so the solution to the function f of x minus the function g of x is, when I combine these, I get -x squared plus 8x plus 2, and the domain doesn't change. So the domain is a set of real numbers for each f of x and g of x, and I know you can't see that, but the domain for f of x minus g of x is also, you could do the set of x's such that x is a real number. You can do that. Or -infinity to +infinity. And this is a quadratic, right? So I can put any number in. My output might be limited, but my input could be any real number for quadratic functions. All right, I'm going to have you try these just to get a little practice, and then be right back and we can compare our answers. Hopefully you've got the same thing I did, and if not, check for your answers. If you can find your errors, that's a great skill in and of itself. So you can see where, I don't know, I was just playing a little bit, having fun with finding the ones that are similar and putting similar marks under them, so I know I was combining it. You could do this, you could do that to match them up, put these under each, yeah. Anyway, since this is a quadratic and this is a quadratic, the domain is all real numbers again. And here you just be real careful with your minus signs and you should be all right. Now we're going to think about multiplying functions. If you think about having a business of some sort, and maybe you're selling, looks like we're selling cell phones here. So the demand in units sold for a company's new brand of cell phones at price X dollars is like this. So the demand is 5,000 minus 10 times X, where X is the price of the actual phone. What's the company's expected revenue from the sale of the cell phones in terms of the price X? So the revenue is my price times my demand. All right. Well, we've already defined the demand to be this. And my price, I could write a function that the price is just X. Now maybe the price would be different in another situation. We're making it very simple here. And the demand, like I said, we've already defined that to be d of x. So since I multiply these two together to get my revenue, I could just write a general form that I would take P of X and multiply it times the D of X. So I take the price function and multiply it times the demand function, and I would get my revenue function. This is a general statement. So if we had more specifics, so maybe they would redo things where they might change the price function, they might change the demand function, but they wouldn't have to change the general statement. We use this a lot in computer programming too. All right, so my price is P of X, and I know that X has to be greater than or equal to 0. Even 0 doesn't make a whole lot of sense, but we know it can't be negative. We can't sell it for a negative amount. Now the demand is 5,000 minus 10x. So this also has to be greater than or equal to 0, which means X has to be greater than or equal to 0. And you could write it out like this. 5,000 minus 10x has to be greater than or equal to 0. And then you could add 10x to both sides, right? When you're adding, you don't change the sign. And you divide by a positive, that doesn't change the sign. So x less than or equal to 500. And we know x also has to be positive, right? So it has to be greater than the revenue. We don't want it less than 0. It could be, but we don't want it there. All right. So let me make sure our revenue, in terms of x, we want our x to be less than 500, which is kind of interesting if you think about it. So if I start pricing it over 500, I'm not going to sell. I'm going to start losing money. I'm not going to make money. I might sell them, but I'm not going to make enough money. So that's what that's all about. Now, for the revenue, when you multiply the domain, this is important. The domain is the intersection of the domains of the things that you're multiplying. So to find a function where you're multiplying, it's the intersection of those two functions. Okay, let's take a look and see what that means. So can you see the steps here that we did? Instead of P, we put in X, because that's the same thing. And instead of D of X, we put in 5,000 minus 10X. We multiplied it out, and we've got this function right here. So that's my function, my combined function of those two when I multiply. And I could graph that if I wanted to also. And you would see it's upside down, so it would make sense that there's a place where I'm going to start losing money right here. This is my X and this is my R of X. There's a place right here where I'm going to start losing money, so I don't want to charge any more than that. And that would be where that 500 would come into play. Okay, I want you to try this one. We've defined D of X and P of X to be something different, but we're doing the same thing. We're multiplying the price. So we're multiplying P of X times, times, let's put an X sign there, times D of X. So we're multiplying those two together. So X plus 16 times negative 0.25 x squared plus 1,000. Use the FOIL method or use the box method and see what you come up with. I did use the box method just because I prefer to do that. And I ended up with this cubic equation here. Now what I might do just to make, I left off, this should be 1,000 here. My apologies. So that should be 1,000. 1,000x. And this should be 16,000 then. I looked at my answer sheet. Let's put another 0 in here. I would probably, it's going to have some limits on it, so I'm going to do a little jump over here to Desmos and type in this one. So y equals negative 0.25x cubed. There we go, get a little froggy out of the way. Minus 4x squared plus 1000x. Whoops. And then plus 16,000. That's a huge number, right? 1, 2, 3. Okay, so I'm going to shrink this down a little bit. Oh my goodness. Okay. We've got some stuff going on here. We see that something happens right about here. 63.25-ish. Something's going on, right? So if this is my x and this is my revenue, it won't be less than 0, right? We don't want to make less than 0. But it looks like my x, which was the price that I'm charging, it can't be more than 63.25. So there is a limit to the domain again. And there is a way you can find that. You could set this thing equal to, so x has to be, you could set this equal to 0 and see what it would be. No, let's do the slideshow. All right, let me see. We're going to do dividing functions. And we've done this a little bit already, so none of this is brand new. But you have to remember that there'll be restrictions on the domain when you divide a function. So f of x divided by g of x, we're just defining them as functions this time. Use a substitution rule for each one. Make sure we factor the denominator and simplify if possible. So f of x is x minus 7. So the function f, oh, that always just does something weird over here, divided by the function g is this. And then on the bottom, we're going to have this 2x squared minus 13x minus 7. Now, it's not in here at this function right there. It looks like, you guys remember how to factor those? So there's a couple ways you can do it. You can think of this has to be 2x squared. This has to be negative 7. I multiply those two together and I get a negative 14. I need the factors of negative 14 that add up to negative 13. Well, that's actually not too hard because negative 14 and 1. So one of these is negative 14x and the other one is 1x. Then I find the greatest common factor. This looks like a 2x here and a negative 7 there. What did I do wrong? Oh, this is just an x. There we go. I did something wrong. 2x, there was my 2x. Okay, and then this would just be 1. So I have two factors for the bottom, the denominator. So I have x minus 7 and 2x plus 1. So you remember that if you have the same thing on the top that you have on the bottom when it's in factored form, that's the same thing as 1. So in simplified form, I would have this. Now hopefully you also remember that we have to look back here and say, well, wait a minute, this can never be 0. So x minus 7 cannot be 0. So when x is 7, the domain it's undefined. So x cannot be 7. And then the 2x plus 1 is 0. So 2x equals negative 1. So x equals negative 1/2. So therefore, the denominator is 0 when this is true. Therefore, x cannot equal negative 1/2. And it cannot equal 7. Those are really important that you remember to put those in when you're dividing. All right, I want you to try this one. You can follow the steps. See those steps? Substitution, substitute the rule for each function, and then factor the denominator and simplify. Try that, and when you get back, we will be finished. You set it up like this, and then you realize this is a quadratic that can be factored. I found the factors of c, which is negative 18, and I found that 3 and negative 6 add up to negative 3, and so x plus 3 times x minus 6, and the x plus 3's cancel out because that's the same thing as 1, and I'm left with this. This is my actual function when I combine those two, and then that's called the rule. That might not be clear there. That's my rule. And the domain, this is my domain. It's all real numbers except x cannot equal negative 3, because if x is negative 3, you would have an undefined. You'd be dividing by 0, and that's breaking one of the commandments of math, one of the rules of math. Well, take a look at, let's see, this is 5.5, day 1, Math Excel homework. Again, ask if you have any questions. Talk to your friends, talk to your teacher, see if you can find the answers.